In this video, we're going to look at how we can find the area of an oblique triangle. We know that it's easy to find the area of a right triangle because we know the area is going to simply be equal to 1/2 times the base times the height. And that's true for any triangle, but we have to know the base of the triangle and we need to know the height of the triangle. But here, we're going to look at how we can use the sine function to find the area of an oblique triangle. So for example, if we have the following triangle, if we label this A, B, C, and then of course this is little a, little b, and little c, and as long as we know an angle and the two sides that make up the angle, we can easily calculate the area. So in other words, if we know angle A, and if we know side B and side C, and really what that means here, we would have, if we know side, angle, side. If we know two sides and what we would call the included angle, which is the angle A here that makes up uh, the angle that's formed from the two sides, B and C. So if we have this side, angle, side, then we can easily find the area of the triangle. And the formulas that you're going to see, if you happen to look in your book or somewhere, the formulas that's going to be given are simply going to be area equals 1/2 B times C, so that's 1/2 side B times side C multiplied by the sine of A. Okay, and that's what we have up here. So if we know little b, little c, and angle A, and again, this is where we have this side, angle, side, then it's simply 1/2 multiplied by the two sides multiplied by the sine of the angle. Now, of course, if you want to rewrite this for the others, you could write it as A equals 1/2 A times B sine of C, or you could say the area is equal to 1/2 A times C sine of angle B. And to me, instead of really trying to memorize this with the letters, I think the formulas here, it's a little bit more confusing when you're thinking of the sides and the angle with B, C, and A. I really just look at it as knowing if I have this side, angle, side, I know I'm going to take 1/2 of the two sides multiplied by the sine of that included angle. So let's look at an example how we can find the area. If we have the following triangle, and let's say that we know this angle is 13 degrees, this is 92 inches, and this side is 30 inches. And keep in mind, I've mentioned this before, but when you're looking at these diagrams in your book, or if you make them yourself, certainly in the book, realize they're not necessarily drawn to scale. All we need is a picture to give us a visual of what we're looking for. So clearly this isn't to scale. If this bottom's 30 inches, then here, side A over here is certainly not going to be 92 inches. But again, this is just a visual to help you see this. So this would be side A, side B, and side C. So if you notice here, we have our angle of 13 degrees, and then we have the two sides that actually make up that angle. So if you notice here, we have the two sides that make up the angle. So that's where we have this, what I'm calling side, angle, side. So if we're trying to find the area, it's just simply going to be 1/2 the two sides multiplied together, which would be 92 multiplied by 30, and then that's multiplied by the sine of the angle. In this case, the sine of the angle, the sine would be of 13 degrees. So then we would certainly just go to the calculator, and if we put this in, we would have 1/2 multiplied by 30 multiplied by 92, and that's multiplied by the sine of 13. And if we hit enter, we end up with 310, and we'll round it to 310.4. So the area is equal to 310.4. And what are the units going to be? Well, this was up here 92 inches, this was 30 inches. So then if we multiply this, inches times inches would give us inches squared. And we know that makes sense because we know if we're finding the area, it's always going to be a square unit. So that means we now have an area of 310.4 square inches.